this program, rather this training. Me, Nicholas, and Christopher. So today I'm pleasured to be taking you through Google Earth Engine, to be specific land cover, land use, land cover, change detection, so that you can be able to, at least we can be able to learn together. Yeah, so am I allowed to share the screen, Nicholas?
Yes, you have the freedom.
Okay, fine. So let me share. Yes, thank you. I hope now you can be able to see my screen.
Yes.
Is it clear, or I need to do something?
It is clear to us.
Yeah, I hope it's clear.
That's fantastic. Nice.
Yes.
Oh, okay. Thank you. So I will start right away because time is running. It's a program. It's actually hands-on talk, so we'll be able to go through the theoretical part, then also code and how it runs. Yeah, so we are the organizers. Then now, just go straight to the introduction. I realized that land use, land cover can be split into two, where we can have the land use and then the land cover. So basically, land cover just shows the amount of region that is covered. Demonstrates how humans utilizes land. So this can be based on maybe developments, conservations, maybe diverse land use types, and so forth and so forth. So the difference is while land cover is focused mostly on cover, for example, forest cover, wetlands. For land use, shows how humans are utilizing the applications. As you can see, it finds its application in natural resource management, in wildlife habitat protection, baseline mapping of GIS inputs, urbanization, logistics and routing, damage alignment, and all that. So basically, land use, land cover has got so many applications which can be of help, especially to the current mid-21st century, where we are experiencing a lot of climate change and different land use patterns. Now, speaking of machine learning, it is a relatively new concept, especially when it comes to the Earth observations, which has got so many applications, especially for the aspect of Google Earth Engine. Now you realize that Google Earth Engine has got embedded the machine learning algorithms, which can be very useful in terms of classification, where we can be the satellite imageries, like for example Sentinel-2, so that we can be able to view how that are readily available to classify the land use land cover, for example, the water bodies, fairlands, croplands, forested areas, and so forth and so forth. Now, after doing that, we can be able probably to do for a period of years. Then we assess on how the land has changed over time. So basically, with machine learning models, to be specific in Google Earth Engine, we can use them for classification tasks, as we'll be able to see as we continue. So machine learning can be actually categorized into several tasks. For example, it can be supervised machine learning classification. It can be unsupervised learning. It can be also regression tasks. Now, with supervised classification, this is whereby we can be able to classify land use based on the ground truth data. So, whereby one has to do manually generate training samples. Based on it, we can be able now to build the machine learning model so that we can be able to classify. Whereas unsupervised classification, this is whereby we can be able to classify land use and cover without necessarily having to use the ground truth data. So you realize that there are several methods or other algorithms already embedded also in Google Earth Engine, where you can be able to cluster or classify land cover. So basically, for regression analysis now, this is whereby you have probably you already have the data set, so you use now the data that you have so that you can be able to predict the future, or you can be able to forecast what will be the future scenario. For example, you can be able to predict water quality based on the available data. You can also be able to predict the percentage forest cover maybe in the next 10 years or 20 years based on the available data, the data you'll be having by that time. Yeah, so all these three tasks can be able to, one can be able to accomplish them in Google Earth Engine. So we continue. Now I want us to actually have now the case study, so that we can be able now to see the code running. So from this end, you realize that first of all, before you do any classification, you need to collect data and then do the pre-processing. After doing the pre-processing, for example, for this study, I just to use LULCC 5 because I was actually doing some kind of time series analysis where I want to assess how land cover for Kisumu East have changed since 2009 all the way to 2022. So from this side, first of all, you have to collect the image. So using this code, as you can see, for this, I'm using now the image collection function so that I can be able to query this ID from the Google Earth Engine catalog. So this is Landsat 5 Tier 1, that is top of atmospheric data set. And then now the next part, I need to filter based on the region of interest using the filter bounds. Now this is the short form of Kisumu East, which is the region of interest for this study. And then now the next thing I need also to filter based on the dates. I'm actually picking the entire data set for 2009 from 1st January all the way to December. Then I will sort using the cloud cover based, and then now use the first function. So what I'm actually doing is that I'll be sorting based on the cloud cover, then select the best, or rather select the image that will be having the least cloud cover. And then the next step is actually generation of the training samples. Now this is very critical because based based on this case study, I'll be using, or rather, the code, the model that is being used is supervised. To be specific, random forest. So first of all, I will have to train, or rather generate the training samples based on the ground truth. So as you can see, and then now for this case, I'll be categorizing into water bodies, vegetation areas, bare lands, uncultivated lands or croplands, bare lands or uncultivated lands, and then croplands, and finally built-up areas or developed areas. So these are the classes that I will be focused on based on that region, which is Kisumu East. And then now here is the code. You realize that after picking all the training samples, the next step you need to do is you need to merge them so that you make a feature collection. So for this case, the order will be water, then I merge it to vegetation, built-up croplands, then finally bare lands. And then now the next step is to highlight, or rather to specify select the bands that will be used in the classification and training. Now for this case, I chose to use band 1, band 2, 3, 4, and 5. Remember, these bands are the same. That is, band 1 is for Landsat 5, band 1 is actually the blue band, then band 2 is green, band 3 red, band 5 near infrared, and then band 4 near infrared, and then band 5 is the shortwave. And then now after that, I will also now generate the points based on the based on the points that I had collected. I'll be able to demonstrate that one when the time for demonstration comes in. Then the next part is now to sample, so that to train the training samples. And here is the code, as you can see. So we are giving it as training, and then now we are training on the image, which is the Landsat 9, which we acquired from this, Landsat 5 2009, which we had just acquired from this past image collection. And then now the next step is training model. Now from this end, we want now to train the machine learning model. For this case, I'm using random forest. So here is the code for training the model. First of all, if you can allow me to switch to the next slide so that you can be able to see detail. This one. Yes. Yeah. So as you can see, the first of all we need to instantiate the classifier. And then the second step, we train the classifier using the training data, the one we just acquired. Then we did the classification based on the feature collected, the features we matched earlier. Then we estimate. The final step here will be estimation of the classification errors. And then for this case, we'll be using confusion matrix. I'll be able also to show you that. So here is the code. If I can try to make it list. I hope you can see. Sorry. Yeah. So here is it. This is the code. First of all, we instantiate using this line of code here. All the way now, the final step here is we can also, for us to be able to estimate the errors, the classification errors, we need to split the dataset into training and testing. Now, for this case, I actually split the data into 70% of training and 30% of testing, as you can see here. Then the fourth step is actually to visualize the classification results. I will be able to demonstrate it from the code so that you can see. But from this end, first of all, you need to specify the visualization parameters for the color palette, and then here it is. So for this side, based on the trained sample and how I merged, water was the first, was coming the first, and then vegetation, built up, croplands, and then barelands. Now from this end, these codes actually you can get it from, they're actually JavaScript codes for the colors. So this is blue, then this is green, the second one for the vegetation, this is red, and then this is croplands is yellow, and then this one is actually brown for the barelands. Now after that, now I need for us to be able to see the classified image, we need to add it to the layer. So we are using the map.addLayer function, as you can see. And then we need also to click to the region of interest so that we do away the entire title of the image, so that we only focus with the region of interest, which is Kisumu East. And then now we are giving it a name. The layer name is LULCC 2009. Remember, we need to specify the visualization parameter. The minimum is 0 to 4. I'll just go back so that I can be able to demonstrate that one to show you what it means by 0 to 4. First of all, what you need to understand is that we are having 5 classes. The first index is 0, but you can even choose to have 1 as your first index. But for this case, I chose to be 0. That's why I'm using the minimum to be 0, then the highest, or rather the maximum to be 4. Yes, and then now the final step here is the change detection. Remember, we are doing kind of time series analysis whereby we want to see how the land use land cover has changed from the year 2009 to 2022. Now from this part, what do we do now for us to be able to get the change detection? We just have to use the subtract function that is already in Google Earth Engine. So rather provided in Google Earth Engine, you can just do a difference of the two images, the classified images, that is the classified images of image of 2002, then we subtract the classified image of 2009, so that we can be able now to see the changes and how it has occurred. I will be able also to demonstrate it. Also, we need to specify and then add it to the layer using that code. Then finally, the last step here is now the computation of the classes, the computation of the areas of each class, or rather LULCC classes. You realize that you can be able to, after doing the classification, you can be able to compute the area of each class using the already available functionalities, as you can see from this code here. So from this part, we are using the reducer region, so that we can be able now to generate the classes, the area for each classes, and then we are converting it to kilometers using this function here, the image to pixel area, then divide so that we have them in kilometers. Then remember, we are selecting all the classes that we are having. Remember, the first one, which is water, is being represented by 0. Barelands being represented by 4 from this end. Then now, yeah, so that is it. So we move on to the demonstration so that we can be able to see exactly what I was trying to demonstrate. Yeah, so give me 1 minute. We move to the demonstration. Yeah, so here is the code. Yes. So from the code, as you can see, I will just go back a little bit so that I demonstrate to you how to generate the training samples before I even run the code, so that you can see this change detection. This is actually the final output. So for us to be able to generate the training samples, first of all, let me do away with this. I think we need to remain with this. Yeah, this one. Yeah, so now for us to be able to generate the training samples, you need to use this tab here. Then you can just create new, like for example, you come here where there is new, just click on new, move it a little bit up so that you can be able to see. So you just click on geometry, then you come to the settings here icon, then you specify what you want to label. For example, if you want to label water, you just do it here, just give it water. So that is the class name. Then make sure you change it to filter collection, and then you come to properties. So here we give it, for example, you can give it class. Then what is the index? You can choose to start with 0 or 1 or whatever you want. So in this case we give it 0 probably. Then after that you specify the color. Probably water can be best represented by blue. Then just click OK. Remember, we already have it, so it's not going to work because we already have water already. So probably you can change it to maybe water 0, maybe water 10, so that doesn't have to overwrite. Yeah, so there it is. So once you have done that, you will have that layer added here. So you come and make sure it's active. Then for you now to start picking the training samples, so you zoom out to areas that are water, or other areas that are covered with water. For example, this one. Now, using the spectral characteristic, you can be able to differentiate water from any other land use, land cover, or from any other feature. For example, in this case, this part that is appearing blue is water actually, so you can just start picking. Okay. Yeah, so you can pick as many as possible. Then you have to make sure that they are well distributed. Make sure that they are well distributed. For example, this water also. Water. Then after that, you have to make sure that you move around the entire area so that you can be able to pick all the waters that are on the image. I think that is okay. Yeah, so that's how we normally get the training samples. The same step remains for the other classes. So you just need to provide. Okay. Yeah, so that is it. So we continue. So if you want to pick also the croplands or any other classes, you just repeat the same process. Then now you pick the training samples. Then after that, so you match all the classes using this code here. This is how we do the matching, so that we have one feature collection. And then now you select the bands that you want to use for classification. Now remember, for this part you can also include other vegetation indices, for example NDVI, GWI, all the bands, so that to enhance the classification. so that you make it as more accurate as possible. And then after that, now this is the part for generating the samples and training them. Then this is the part where now we can be able to visualize, defining the color palette, then adding the layer. So let me just demonstrate it right away. Now for us to be able to run this classification, you can choose to do maybe control, enter, or we just run from this end here. So it's going to take some time. Yeah, any question? Probably, maybe. Yeah, so that is it. If I can be able to uncheck this one so that I only remain with the classification. I want to remain with the classification for to do away this. Yeah, now this is the classified image for 2020 for 2022. As you can see, this lower part here is Lake Victoria. It's well classified. So this is a lake. The ones you are seeing as green are the vegetation or forested areas. Then now the red part is the build-up. These are the built-up areas. The purple one is the barelands, and then now the yellow is actually showing croplands. Now you realize that this classification was not well done because of there's also vegetation or other croplands appearing in the lake, but it's not as much as not very badly classified. Yes. Now another part also I need to show you is from the console. Let me just make it a little bit visible. Okay, now for us to be able to assess and evaluate our classification, just like I said, we need to evaluate. For this part in Google Analytics, there is already confusion matrix functionalities embedded in it. Maybe I can just show you the code. So here it is. So from the error matrix, we can be able to compute the errors so that we can be able to assess how the classification. For this part, we can be able to show the overall accuracy and the kappa statistics. For this part, the overall accuracy is 0.841. And then now the kappa statistics is around 0.75. So this is 77. Sorry. So this is this shows that the classification was done well. It was not that badly off because it's above 75%. Now this is for 2022 code. Yes, and then now for the other time. So and then now the next part is the areas. For us to be able now to see the computed areas for specific classes, we can also see it here from the code. It was somewhere here. Now this is the code for computing the areas of each class, and then this is the output. Remember, we are printing it 22 area of classes. Can you see it here? So it's printed here. If I click on it, you realize that each class has been the area for each class has been computed and then now printed over here on the console. Same to the one for 209 is here. Sorry, I forgot to change this part, but it's supposed to be 209. Yeah, so I think I'm done with the presentation. Yeah. thank you so much.
Okay, so thank you very much, Mr.
Thank you,
Michael.
thank you.
Yeah. Ernest has raised hand for several times. Maybe Ernest, you can say something, please. Ernest. Okay, so it's okay. So we are really much grateful, Michael, for the good presentations that you have shown to us. Launch cover land change detection is very, very useful. And as you mentioned earlier, is that its applications are many. So I do believe that each one of us here has learned something great, and we really much appreciate it. So the other question which I've seen most of us are inquiring is about the sharing of the recording and also the presentation. This one is being taken into consideration, and we are looking into that. We will be sharing the presentation before late, so we are going to have that. Even the previous presentations, we are going to share them with you all, because they are good for reference in any time we are working on a project. So we are great. So there is here, Poda is asking us, Michael, there is a question here from Poda who wants you to explain more about the training and testing data. So if you won't mind, please, you can take over to respond to Poda. Please, Michael, please.
Okay, thank you so much. Yeah, thank you, Poda, for that question. I need just to go back to the training a little bit so that I can be able to, rather I can use the code. Okay. Yes, so remember when I started, I said that for us to be able to do the classification in Google Earth Engine, we have a choice. We can probably choose to work with unsupervised classification or work with supervised classification, unsupervised or supervised. Now, for this case, I chose to work with supervised because, for the sake of this demonstration, and then also remember with the supervised classification, we need to train the samples based on the ground truth. So for us to be able to assign classes to specific land use, land cover classes, or assign values to them, so that we, like giving them labels, we have to use we have to do the sampling. Now for this case, let me just go back to the code, then maybe I do it again where I didn't capture it well. Now for us to be able to generate training samples, you need to follow the steps that I just mentioned earlier, whereby you have to come to geometry imports, and then now you start selecting. First of all, you specify the class you want to pick the training samples. For example, it is water, or if it is vegetation. Then after selecting and creating a new layer, like this one, then you come to now configure geometry import. Now from that point, you give it the label name. Remember, we want to give it vegetation, so you specify the name of the class, which is the label, and then on import as, you have to make sure that you select feature, you make it feature collection. Then after that, you come even choose to begin from 1 to the number of classes you'll be having. Probably now for this one I choose to work with 0 to 4. So 0 was the first index representing water. Then after doing that, you just click OK. Then for you now to start picking the training samples, you make sure that it is active here. As you can see, the one that is active is it's bold. The others are actually not bold. So you make sure it's bold here. Then now you just come to the image that you want to generate the training samples on. This is this one. Yeah, like for example this one. And then now you start picking the training samples for each specific class. So for you to be able to run a random forest or any machine learning accurately, first of all, there's so many factors you need to put into consideration. You need to make sure that there's no overfitting. For information, random forest does not suffer so much effects of fitting. But now you have to make sure that like the training samples you're picking, first of all, they give the true representation of the entire area, or rather they have to be widely distributed. Then after that, once you have generated all the training samples for specific classes, so you need to split your data set. I believe this is where now Porter was asking. You need to split your data set into training sample and testing. Now for this case, training sample will be used now for the training of the model. Then the testing will be able to help us in evaluating the model. Now for this study, I chose to work with 70% training samples, and then now 70% training sets, and then 30% testing sets. But you can even have 80% training sets, and then 20% testing sets. So from the testing set, you can be able to evaluate the model and do the testing and see how it has performed. For instance, as you can see here, we are able to see that the model did not actually performed very well because it was having an overall accuracy of 0.84, which can be translated into 84.16%. That is for 2009, and then the other one was around. I didn't change it, but the other one was around 97%. I didn't include it here, but I can always change it. Okay. Yeah. So I hope I have answered the question Porter has asked earlier.
Okay, maybe Panda can say, oh, he's okay with that, so he's very happy. So we are going, somebody here, Yasmin is raising her hand. Maybe. Yes, please.
Yes. So I actually have joined a little late, and I couldn't see from the beginning. Is it possible to get the slides and the recording?
Yes. So after this, it will be able to be posted. So, and I think Nick can be able to on this.
Okay. Then now for that, we are going to share the presentation very soon. And Yasmin, if you are not in the Google group, you can share your email in this GE Devs Nairobi, because there is all where we will be able to share. We are also preparing a blog whereby, and also the GitHub, and where we will be able to host all the codes which are being presented here, and the blog, a dev2 blog, where all the presentations which are theoretical and not code based can be shared for references. But our code will be shared in the GitHub repo, which now we'll be able to share with you the link for that. I believe that will be much helpful.
Yes.
Yeah, good.
Yeah.
Yes, thank you. I have shared my email and I have another question. Like I'm not well aware of Java. Even though I don't know Java, will it affect me? Like, can I do it without it?
Yes, it's a very okay. It's not so much hard for you to get started because it requires a little a brief a little bit of an understanding with JavaScript. Also, if you are good in Python, we will also be having sessions which use Python for this because Google Earth Engine uses two APIs which are Python and JavaScript. So whichever best you will find is suitable for you, it can help you to get started and be able to work on good projects with this. So, but for JavaScript, it's very much easy for you to get started and working on something great.
Yeah. So again on JavaScript, Google Earth Engine has a very good documentation on the same. So I believe when you follow the documentation, it's very well explained. Yeah.
Thank you. Yes, I understand it, and I've seen many other people also mention their email address, including me. I hope we will get back from you.
Sure, very sure. You are going to get it. So I am not sure. So I want to share with you the Google group, which is so much big, and which we thought it could be much better as compared to the WhatsApp group. Are you able to request in that? Are you able to request invitation in that? If not, I want to share with you the Google form so that I can send with you the invitation. I'm sending right now. The registration in the Google form, so where you can register all those emails. Then on our side, we send you an invitation which you will be able to accept. Once you are now able to accept that invitation, it will be much easier for you to be getting all the communications and whatever is going to happen, all the events and everything. Okay, so I'm just getting the link for you to share with you so that you can just register there instead of anything. Please, in a moment. Somebody with any question, any clarification can also go on as we sort out this, please.
I can see there's a question. Kindly say again JavaScript material. I don't understand.
So I think it's regarding the documentation. So
Okay.
Google Earth Engine documentation.
Oh yeah. So
Yeah. So
the good thing with Google Earth Engine actually, there's a lot of materials online, and then also it's not very hard to start if you are new in JavaScript, but still if you are good in Python, that's like Nicholas said, you can always have a start because there's already an API in for Google Earth Engine in Python. Then there is also the one for R, and then also you can actually also link it to QGIS and then work within the QGIS environment. So there's a lot of possibilities that you can always seek to maybe look into it, rather look into them.
Daniel, we are sharing with you the link right now, the documentation link right now. So, but as we share with you the link, this is the form whereby you can just fill the name and the email. You are not well because now once you fill this, will send you an invitation link to the Google group whereby you will be able to join. I think this will be much faster and much easier for you. So that is the form. You can just register register there. No many details, just register, then we will share with you the invitation to the Google group. That will be very much fast for you and also on our side. Then Marley is asking, Godfrey please just fill that form so that we can send the invitation to all the members who have filled in that form, please. I hope that will be much easier. Then here we have Marlal, who is asking how can he download the data from Judge's disk site for period of 20 years. Michael, you can help in this, please.
So it is precipitation data. What Maral can do actually, you can use CHAPS data. So I will be able also to share the link. I can share the link to CHAPS data, but still you can be able to download it directly from also Google Earth Engine for 20 years. Okay. Yeah. So I will share the link, but you can be able to download it from Google Earth Engine also.
Alright. Okay, so I'm sharing the link asked by Daniel right now. Google Docs. Please. Right. Okay. So this is the documentation. Documentation. Here it is. But if you have any question regarding, if you get stuck in the documentation, you can always ask in the Google group or even here during the sessions, so you will be able to get answers of any challenge you face. So I think that is good. Any question, please? The link. Now, Mark, which link are you referring to? Yes, get it. We are going to share it in the Google group, which is already existing. Okay. Then, Marl, you want the link for the presentation, right, Marl? Okay, so you are going to get it. We are going to get it in the form. Okay, so the last question, the last part, don't fill anything, just fill the necessary fields, please. Just that. Okay, so any other inquiry or any other concern for this? Okay, so thank you very much, Moses, for that. We are going to have more of this presentation in the coming weeks. Then we are hoping to have a speaker next session, next Saturday. Now this could be, so it's not confirmed. It could be an expert session whereby we'll have a member, an expert talking about to us about all the innovations surrounding what we are doing. But then we are going to have another session on machine learning on this using the Google Engine, still an enhancement of this. So we are going to have more of this till a point whereby we will feel like everybody is capable of doing something by his or her own. So more of these sessions are coming.